the end of 1993, all aircraft entering or operating in the USA with a seating capacity of 30 or more will be required by FAA regulation to be equipped with TCAS. Consequently, at that time, the skies of Europe will contain a large number of TCAS-equipped aircraft. So, what is TCAS? TCAS is a traffic alert and collision avoidance system. And that is part of a family of airborne collision avoidance devices known as ACAS that function independently of ground-based air traffic control. Basic TCAS 1 provided traffic advisories, or TAs only, whilst the current TCAS 2 not only provides these proximity warnings, but at a certain point recommends an escape maneuver or resolution advisory referred to as an RA in a vertical direction to avoid conflicting traffic. The current logic or phase of development of TCAS 2 is Logic 6, currently being installed in aircraft in compliance with the FAA regulation. It is this system we will initially explore to illustrate the basic principles before examining the new Logic 604 with its more refined operational parameters that is currently being evaluated and is expected to enter service as a software modification in early '94. The purpose of this videotape is to reassure air traffic control personnel and provide a better understanding of what is, in essence, an airborne safety net that only comes into its own when normal separation has already been lost. Even so, it must be remembered the system cannot predict sudden changes to the current profile of an aircraft and is therefore not the ultimate answer to airborne collision avoidance. Here's how it works. The system detects other transponder-equipped aircraft, predicts their flight path, gives ample warning of a potential hazard, and suggests a corrective action. The airborne equipment consists of 2 antennae, one directional and one omnidirectional, the latter normally on the underside of the aircraft. On the flight deck, the transponder control panel includes controls for TCAS 2. The system also includes a method for presenting visual information, but that varies according to the configuration of the flight deck in question. For those that have a traditional analog vertical speed indicator, that indicator is replaced by a flat LCD panel. When TCAS 2 activates, the display is added to the vertical speed information. Flight decks equipped with an electronic flight information system enable TCAS 2 data to be added to the existing functions. In either configuration, TCAS 2 does not communicate with ATC, but remains as an in-flight aid to the flight crew.
Traffic, traffic.
A speaker system provides audible enunciation to reinforce the visual representation. So, how does this work as a system? It first establishes a three-dimensional collision area around the aircraft. The higher the altitude, the larger the protection area. It's important to understand that TCAS 2 protects against more than just an encounter with an actual aircraft. More accurately, it protects the collision area from penetration by another aircraft. To do this, it scans the area around the aircraft every second, interrogating other transponder-equipped aircraft. When it receives a response, it uses the telemetry data in a mathematic formula of range over range rate, which calculates closing rate vertically and/or horizontally. If it is calculated that an aircraft will indeed enter the collision area, the system adds a cautionary and then a warning area and calculates a new size and shape. That's because it looks at the time to a potential penetration of the collision area and not the distance. Therefore, as the geometry and closing speed of the aircraft changes, so does the protection. The perimeter of the caution area is approximately 40 to 45 seconds from the time TCAS-2 calculates that the intruder will enter the collision area. The perimeter of the warning area is approximately 20 to 25 seconds away. If the intruding aircraft continues as predicted and enters the caution area, TCAS-2 designates it as an intruder and issues a traffic advisory, or TA, which is audibly announced to the pilot as follows.
Traffic, traffic.
Let's now examine what the flight crew see on their instrumentation, remembering that the information presented to them, whether via an electronic flight instrumentation system or an analog liquid crystal display, from our point of view, it is exactly the same. The symbol in the lower center represents the TCAS-2 equipped aircraft. The scale in this instance is 6 miles ahead, 4 miles to each side, and 2 3/4 miles to the rear. The surrounding ring is 2 miles out. An intruder can be shown in a number of ways. An aircraft equipped with mode alpha only, normally as a solid amber dot at the relative bearing and range. And if the aircraft's transponder is providing mode C or mode S altitude information, the system will add a data tag with vertical separation between the aircraft and the intruder shown in hundreds of feet. If it's below, then the intruder is lower. A plus or minus symbol confirms this to the pilot. If the tag changes position, then the intruder is passing through that aircraft's altitude. If the intruder aircraft is climbing or descending at a rate greater than 500 feet per minute, an arrow appears alongside the symbol pointing in the appropriate direction. If the intruder is beyond the scale of the display, but still within the 40 to 45 seconds before penetrating the aircraft's collision area, half of the symbol is positioned at the edge of the display at the proper relative bearing. This would occur if the two aircraft had a very high closing speed. Depending on the circumstances, a portion of the data tag may be masked by the edge of the display. Another variation occurs if the fuselage of the TCAS-2 equipped aircraft temporarily blocks the line of sight of the directional antenna to the intruder, or if this antenna fails. In either situation, the system is not able to determine the relative bearing, so it shows only a modified data tag. It states to the pilot the intruder's range, relative altitude, and, when appropriate, an arrow to indicate vertical speed in excess of 500 feet per minute. When the antenna's line of sight is restored, the display returns to normal.
Traffic, traffic.
This traffic advisory is presented to the flight crew only to assist in a visual search for the intruder and to prepare them for a possible resolution advisory. It is important to make clear that avoidance measures based solely on a traffic advisory are definitely not recommended. If the pilot's visual search is not successful and the intruder continues to actual entry of the warning area, TCAS-2 issues a resolution advisory, or RA, of which there are two kinds. The corrective resolution advisory instructs the pilot to make a specific change to the existing vertical movement rate, and a preventive resolution advisory instructs the pilot to avoid certain changes to the current vertical movement rate. During either of the resolution advisories, the symbol of the intruder presented to the pilot changes to a solid square and the color to red.
Climb, crossing, climb. Climb, crossing, climb.
For a corrective advisory, the pilot must promptly and smoothly initiate a 1/4 G maneuver to position his vertical speed indicator just outside the illuminated red prohibited zone into the green fly-to zone. In most cases, this maneuver will go unnoticed by passengers and cabin crew. If you have already instructed a vertical maneuver, the TCAS-2 instructions to the pilot could be:
Increase climb. Increase climb. Reduce climb. Reduce climb. Increase descent. Increase descent. Reduce descent. Reduce descent.
The system can analyze very complex traffic situations, and it may direct the pilot to maneuver across the intruder's current altitude, which in itself may seem unusual to the pilot and controller. The TCAS-2 synthesized voice instructs:
Climb, crossing, climb. Climb, crossing, climb. Descend, crossing, descend. Descend, crossing, descend.
And for a preventive advisory,
Monitor vertical speed. Monitor vertical speed.
the pilot must simply keep the indicator out of the red zone. Since the vertical climb rate you have instructed is perfectly acceptable, there is no green fly-to zone. Once the potential for the intruder to penetrate the collision area is eliminated, the instrument reverts to its normal function, and the system audibly announces this to the pilot.
Clear of conflict.
The pilot then promptly and smoothly returns to his assigned flight path. On aircraft fitted with an electronic flight information system, the TCAS-2 information is presented on the navigation display if the range selected is 40 miles or less. When TCAS-2 wants to present an advisory and the range selected is greater than 40 miles, it adds the word traffic or TCAS to the display. This alerts the pilot to change the range of his display. The maneuvering instructions and the red prohibited and green fly-to zones are shown on the vertical speed tape. Regardless of how the information is displayed, the system logic and symbols are the same. Whilst a TCAS-2 resolution advisory is in progress, the geometry of the encounter is constantly monitored and the maneuvering instruction can be changed.
Increase climb. Increase climb.
Would follow a previous climb advisory to instruct the pilot to increase the rate of climb, in this case to 2,500 feet per minute.
Increase descent. Increase descent.
Would follow a previous descent advisory to increase the rate of descent, in this case to 2,500 feet per minute.
Climb. Climb now.
Would follow a previous descent advisory instructing the pilot to reverse vertical direction.
Descend. Descend now. Descend. Descend now.
Instructs the pilot to reverse a previous climb advisory. Now let's look at a typical TCAS-2 operation. While cruising at flight level 310, TCAS-2 designates an intruder and issues a traffic advisory.
Traffic. Traffic.
The pilot flying observes the display and begins the visual search. The pilot not flying also observes the display and audibly confirms the range, bearing and altitude of the intruder, then joins the visual search. The search is not successful, and TCAS-2 issues a resolution advisory.
Climb. Climb. Climb.
The pilot flying clears the appropriate airspace and promptly alters the vertical speed with a 1/4 G maneuver to move the VSI out of the red and into the green fly-to zone. The pilot not flying, of course, continues the visual search and monitors the intruder's position on the TCAS-2 display. He also verifies that the pilot flying is correctly following the resolution advisory. The maneuver has eliminated the potential for a collision.
Clear of conflict.
The display reverts to its normal function, and the pilot flying promptly returns the aircraft to the previously assigned flight profile. Now that you are familiar with the basic operation, here are some additional features and general information. During either a traffic advisory or a resolution advisory, TCAS-2 displays not only the intruder, but also indicates to the pilot any additional traffic. This creates additional traffic awareness should a maneuver be necessary. Any aircraft that is within 6 nautical miles horizontally or within plus or minus 1,200 feet vertically is designated as proximate traffic and is shown to the pilot along with the intruder as a cyan or blue filled diamond and data tag. Additional aircraft within the range of the display and within the switchable vertical display range of 2,700 feet above and 7,000 feet below, or vice versa, is designated as other traffic and is shown as an open cyan or blue diamond and data tag. If the system is tracking multiple aircraft during an encounter, it displays only the intruder and those designated as proximate traffic. At altitudes less than 500 feet above ground level, the system does not provide resolution advisories, but will provide traffic advisories. The pilot can also use the system to learn what traffic is in the vicinity when there is not a threat of an encounter. With the traffic switch in the on position, the display will present all transponder-equipped aircraft within the scale, plus or minus 2,700 feet vertically. The number of resolution advisories which have occurred during trials of the system in the USA are expected to be substantially reduced with the introduction of the new 604 logic. The deviation required to resolve an encounter from an intended vertical flight path is relatively small, normally between 200 and 500 feet. If the intruder is also equipped with TCAS, the systems communicate with each other to ensure that avoidance maneuvers are coordinated and complementary. Now let's examine once more the main features of this airborne collision avoidance system. TCAS-2 detects other transponder-equipped aircraft, predicts their flight paths, and gives ample warning of a potential hazard. It then suggests a corrective action. TCAS-2 first establishes a three-dimensional collision area around the aircraft, the size of which varies with altitude. It protects this collision area from penetration by another aircraft by predicting the potential intruder's flight path. Around this collision area, TCAS-2 adds first a cautionary area and then a warning area, then calculates a new size and shape according to the flight profile of the intruder. The system looks at the time it would take to penetrate the potential collision area and not the distance. And as the geometry and position of the intruding aircraft changes, so does the protection. Once an intruder penetrates the caution area, which is approximately 40 to 45 seconds away from penetrating the collision area, the system issues to the pilot a traffic advisory, or TA. At the perimeter of the warning area, approximately 20 to 25 seconds away from the collision area, the system issues a resolution advisory, or RA. The TA is presented to the pilot to assist him with a visual search, and avoidance measures based solely on a TA are definitely not recommended. If the pilot's visual search is unsuccessful and the intruder continues its trajectory and penetrates the warning area, the RA that is issued to the pilot will either be a corrective advisory or a preventive advisory. The corrective RA instructs the pilot to make a specific change to his current vertical rate, and a preventive RA instructs the pilot to avoid certain changes to his current vertical rate. The system can analyze very complex situations and may direct the pilot to maneuver across the intruder's present altitude. So, The enunciation of this corrective RA to the pilot will confirm the instruction.
Climb, crossing, climb. Climb, crossing, climb.
For a preventive RA,
Monitor vertical speed. Monitor vertical speed.
and the pilot simply keeps the indicator out of the red zone. Since the current vertical rate is already acceptable, the pilot has no green fly-to zone. Once the potential for the intruder to penetrate the collision area is eliminated, the pilot's vertical speed indicator returns to its normal function, and the system informs him,
Clear of conflict.
the pilot will then promptly and smoothly return to his assigned flight profile and notify ATC as soon as possible. ATC should then note the avoiding action taken. But remember, response to an RA may result in a loss of standard ATC separation. But of course, that is better than no separation at all. It may also affect your overall tactical plan. So far, we have been discussing the current technology of TCAS 2 Logic 6. But currently being evaluated by the FAA is the improved TCAS 2 Logic 604, which offers much greater confidence to flight crews and controllers alike, with its greatly reduced nuisance resolution advisory level with legally separated aircraft. Taking off from Paris-Le Bourget on October the 8th, 1992, two FAA aircraft, a Boeing 727 fitted with TCAS 2 Logic 604 and specially fitted observer display screens in addition to the pilot's conventional VSI display, and a Beechcraft King Air 200 acting as intruder aircraft, demonstrated this greater confidence with convincing effect. Having first established instrument calibration, the two aircraft separated in order to take up their positions 12 nautical miles at opposing ends of a common VOR DME, in readiness to begin Encounter 1, a head-on encounter at a closing speed of 460 knots with a vertical separation of 450 feet. With TCAS 2 switched to on, the transponder-equipped King Air can clearly be seen as an open diamond target at a range of 12 nautical miles at an altitude 500 feet above the 727. This is how the controller screen showed our two aircraft approaching each other. At 5.9 nautical miles, the audible warning informs the pilot that the King Air has become a traffic advisory and is illustrated on the TCAS display by changing the open diamond to a solid dot.
Traffic, traffic.
At this point, the controller screen appears like this. At 3.9 nautical miles, the traffic advisory becomes a preventive resolution advisory.
Monitor vertical speed. Monitor vertical speed.
Subsequently, as the intruder again changes altitude to below 500 feet separation, a corrective resolution advisory is issued.
Descend. Descend.
With the prior knowledge of the encounter outcome, and to illustrate the effectiveness of the new 604 logic, no corrective measures were taken during the demonstration. As the threat diminishes and the 727 passes safely beneath, the audible warning informs the pilot that he is now
Clear of conflict.
and this is clearly shown on the controller's radar screen. In a real situation, of course, we must stress that the moment minimum separation was lost, ATC would have reacted well before the traffic advisory had occurred. Demonstration 2, known as the Dallas Bump Up, illustrates a typical scenario where an aircraft climbs towards another in level flight. In this encounter, the 727 is flying at flight level 140, and TCAS-2, now looking to a maximum of 7,000 feet below and 2,700 feet above, has located the King Air 3,700 feet beneath. This scenario calls for a climb rate of 2,500 feet per minute. The closing speed is 500 knots. From the open diamond and tag, the climb rate in excess of 500 feet per minute can be clearly seen. This is how it looks on the pilot's TCAS-2 display screen, and this is how it looks on the controller's radar screen. The King Air, call sign November 35, can be clearly seen climbing towards the 727, call sign November 40.
Traffic.
Now at a distance of 5 nautical miles and 1,500 feet below, and with the intruder's climb rate still greater than 500 feet per minute, a traffic advisory is given.
They had a lot of trouble with the carriers. You probably heard them. Put on bad stocks about them. They're not interrogating a lot of them.
Traffic.
The intruder aircraft levels off 900 feet below the 727, at which time another traffic advisory is issued. With the earlier TCAS-2 Logic 6, a corrective climb advisory would have been issued, even though the aircraft were legally separated. But with the 604 logic, the resolution advisory would not have occurred until 450 feet later, less than 500 feet separation. With its redefined parameters, the new logic will inhibit traffic or resolution advisories below 1,000 feet above ground level, a major refinement alleviating nuisance advisories from adjacent runways and localized traffic when taking off or landing. Although not expected to enter service until 1994, the new 604 logic of TCAS-2 will most certainly provide a greater degree of confidence to air traffic controllers and pilots alike. The information provided by airborne collision avoidance systems is intended to assist pilots in the safe operation of aircraft. It assists pilots in the search for and visual acquisition of conflicting traffic and does not prevent them from exercising their best judgment and full authority in the best course of action to resolve a traffic conflict. It is not intended that pilots maneuver their aircraft based solely on a traffic advisory, and even with a resolution advisory, the alteration to the flight path shall be limited to the minimum extent necessary to comply with that resolution advisory and never in the opposite direction of that advisory. Again, it must be stressed that any form of ACAS is there to act as a safety net should, for any reason, legal separation be lost. It is envisaged that future ATC training shall include the capabilities of ACAS, especially its ability to track more than one aircraft and issue resolution advisories that provide adequate vertical separation for more than one intruder. It is essential that air traffic controllers receive detailed training on the operation of ACAS and its potential impact on their operations. As a minimum, controller training is expected to also include the parameters used by ACAS when issuing advisories and the vertical separation that ACAS is designed to provide. Training will also include the types of displays available to pilots of ACAS-equipped aircraft and the information presented by them. Controllers will also become fully conversant with the procedures pilots are trained to use in response to TAs and RAs. However, as we're about to enter the 21st century, the implementation of ACAS and its family of airborne collision avoidance equipment should give further confidence to those already dedicated to the world of air navigation safety.
KLM 145, turn left heading 350.